Now we begin to discuss a little bit more explicitly how we test for differences between groups using statistics. So the focus of this portion of our time together in week 3 is really going to dive a bit more in depth at looking at how do we understand test for differences between groups. So of course in our roadmap we're here at the analyze stage. We've done our descriptive statistics on these data and variables of interest. We've looked at how data are distributed, what measures of central tendency are, the variance around the measure of central tendency, and relationships between variables using things like correlation coefficients. So now we're going to look at how we test hypotheses and test for differences between groups. So what is hypothesis testing? Before we can really understand that, let's look again very briefly at the relationship between variables. We've talked about how the foundational concepts in our time together are looking at predictor and outcome variables. We're always going to be coming back to these concepts. What is the predictor variable and how is it related or not related to the outcome variable of interest? And all of our statistics will enable us to more effectively describe that relationship than we could with simple descriptions or graphs alone. We talked in our previous session about how the sample size, typically listed as n, is related to the confidence interval. So when a confidence interval is a measure around the point of central tendency that tells us how certain we are, how likely it is that the observed value of central tendency that we obtained would be present in the population that our sample is drawn from. So it's a statistical measure to show us how confident we can be about that measure of central tendency and how confidently we can believe that that measure would also be in the population of interest. So the larger our sample size, the smaller our confidence interval, because we have more points of information to understand our measure of central tendency. And the smaller the population that we're studying, the smaller our sample, the broader our confidence interval. So as we understand the confidence intervals, they will help us to understand how the data that we have in our sample is related to the population that we're studying. So what is hypothesis testing? So there are two key concepts we want to look at. The first we discussed already is the 95% confidence interval. It's the range around our measure of central tendency, in this case the mean, in which we expect observations to lie when we're thinking about the relationship between our sample and the population. So let's see how this concept of central tendency applies to our data set. We're going to look at the number of heart failure readmissions, and let's begin by looking at those in New Jersey. And we'll go back and run our analysis in SPSS to see what the mean value is for New Jersey's heart failure admissions and what's a standard deviation around that mean. So now that you've opened up your data set in SPSS, what I'd like for us to do is go to Analyze, Descriptive Statistics, and Explore. Now I want to show you an additional powerful option in SPSS for exploring the descriptive statistics for our variables. So we'll select that option and scroll through your list here on the left and select heart failure readmission excess as your outcome variable. And the factor list here I'd like to select will be the state. So we're going to see how the hospital readmission excess ratio compares state by state. And you can select statistics. Here we'll also give you graphic diagrams, but we're not going to talk about those at the moment. So let's run that analysis. And the output is going to show us by state what the excess hospital readmission ratio is for heart failure. And so we have a table here that gives us some summary statistics around that. that are background for what we're going to talk about, let's dive into the descriptives table. And you can see here the outcome variable of interest is heart failure readmission, the excess ratio. And then in this column, we have listed all the states. And by state, we get an amazing breakdown here of descriptive data. So let's scroll down through this table and find the data on New Jersey. Okay, so we found New Jersey. We see here that the mean excess readmission ratio in New Jersey is 1.0606. So that's how this function works to get state-by-state data. Now, let's run that same analysis, but this time consider the total number of heart failure readmissions. So we'll go to Analyze tab, Descriptive Statistics, Explore, and this time, instead of heart failure readmission, let's remove that one, let's go to the total number of heart failure readmissions instead of the excess ratio. We'll again factor by state, look only at statistics, and ask it to generate those data. The first table is background, and here now we're looking at the total number of readmissions. Again, let's scroll down to New Jersey. And here we have the mean number of readmissions for New Jersey is 194.3. The standard deviation is 117.8. So let's take those data back to our PowerPoint discussion. So in New Jersey, we have 194 heart failure readmissions per facility, plus or minus 117.8. So 194 is the mean, 117 is the standard deviation. So if we look at Wyoming, let's see how that compares and then graph these two together. So here you see Wyoming has a mean heart failure readmission number of heart failure readmissions of 27.5 per facility. And if we look at the standard deviation, we find that's 22.4. So let's put those back into our PowerPoint presentation. and we see that 27 plus or minus 22. Now let's compare Wyoming to New Jersey using this measure of standard deviation. So if we look at the number of heart failure readmissions by state, see Wyoming has 27 as the mean. So now if we plot those data conceptually, we see that Wyoming has a mean total number of heart failure readmissions of 27 per facility. New Jersey has a mean of 194. But the confidence interval for Wyoming actually crosses 0. You see it starts at -17 and goes to 71. So why does this happen? Of course, we know that a hospital can't have -17 readmissions. And when you see the confidence interval crossing 0 for a number whose scale is 0 and above, it's an indicator that the data are not normally distributed. And so it's just one little tidbit to think about. But we see that the range of Wyoming's of mean is between -17 and 71 when we look at the 95% confidence interval. And for New Jersey, there's a maximum of 311 all the way down to 77. So you can see that these two confidence intervals for the mean number of readmissions for heart failure per facility does not overlap. So what does that mean? And how does that compare when the confidence intervals do overlap? Now, in our example, the confidence intervals didn't overlap. So it suggests that there's a statistically significant difference between Wyoming and New Jersey when we think about the total number of heart failure readmissions. But if these confidence intervals were to overlap, it means that we're not able to statistically conclude that these two groups are different. So That brings us to the concept of a research hypothesis and a null hypothesis. Oftentimes a research hypothesis is stated something like there is a difference between the number of readmissions for Wyoming compared to New Jersey. And it's a practical way of stating what you're interested in, what you're curious about. And that's different than a null hypothesis. But we need to talk about the null hypothesis because that's the foundation for understanding statistics moving forward. And it's slightly counterintuitive, so I want to be sure we spend a bit of time talking about it. Now, a null hypothesis says there's no difference between groups. Null, none. So it's a none hypothesis, or a suspicion that there is no difference between the groups that we're considering. However, when we think about statistics and testing, there's language about rejecting the null hypothesis. So what that means is the confidence intervals of our two groups do not overlap. They're different, they're distinct. So when the confidence intervals are not overlapping, it suggests that there's a difference between these two groups. Now you can never say for certain, but statistically speaking, there's no statistically significant difference between group A and group B. That's your null hypothesis. So consequently, you reject the null hypothesis when the confidence intervals do not, in fact, overlap. So spend a little bit of time with this slide, trying to get the concept down, reviewing the text, looking at some online resources, because it's an inverted way of thinking, and it takes a little bit of time to percolate with and think through to really master. Now, let's take the flip side of the coin. We would fail to reject the null hypothesis when the confidence intervals overlap. Because remember, the null hypothesis is there's no statistically significant difference between group A and group B. And so when group A and group B's confidence intervals overlap, we say that we can't tell if these groups are statistically significantly different. So when the confidence intervals overlap, like these two do right here, we fail to reject the null, because the null hypothesis is that group A and group B are not different. So we fail to reject it, meaning we can't conclude that they actually are statistically different when their confidence intervals overlap. So by convention, the point of accepting or rejecting a null hypothesis is at the 0.05 level, at the 5% level. So we say we're comfortable taking a risk 5% of the time, making an error in accepting or rejecting the null hypothesis. So this is where the idea of 95% confidence interval comes from. We have a 5% chance of making an error. It's just as depicted here on the tails of your distribution. So remember that 0.05 is the level at which we decide to accept or reject a null hypothesis by convention. Certainly not an absolute right or wrong, or a definitive, clearly the best way to do statistics in the universe, but it's the way that statistics have been done for decades, and it's the commonly accepted standard in the field, unless you have a clear rationale for setting another significance level. So each of the models that we've talked about is based on assumptions. So if we want to test differences between groups and we pick a statistic to make that test, we have to think about the assumptions of the statistic. I've showed you the confidence intervals and how they overlap, and that's foreshadowing to move us to this next step of considering how each statistical test has assumptions, and we need to check our data to make sure the test and our data fit before we use a particular test. So with that, we'll conclude our conceptual discussion about hypothesis testing, and we'll move toward our next session where we look at practically running these tests and some of the assumptions behind them. Have a great day.